So guys, this is how the Azure portal looks like. This is the demo of our EL part. So I have signed into Microsoft Azure portal. So what Microsoft does is gives a Microsoft Azure portal where we can run all the cloud related activities that concern Microsoft Azure. So it can be used for practicing where we can use a number of services freely offered by Microsoft. Uh, for different cloud services like Azure, it's different. But here in Microsoft Azure portal, we get some free credits. It's $200, which can be used for 11 months, and post that they expire. So if anyone doesn't have that account, so you can uh, get the free credits and use the free account. For students, you can also use Microsoft Student Portal, which can be used, and you'll be getting some credits which you can use to buy the services. Uh, you can also log in using GitHub Student, so that can be used for using Microsoft Azure services. So this is how the starting portal looks like, but the free version has some restrictions to it. So after registering, I have already registered and logged in. Now, coming to the demo part, what we are going to do is we'll use Kubernetes cluster, and on top of that, we'll be deploying some application over it. So that app is already built by Microsoft Azure. We'll be using the same application and deploy using Microsoft Kubernetes. So you'll be using that pre-built application over Kubernetes clusters. The main thing is to note here is how easily the cluster is deployed, and we need not care about orchestration. So uh, moving to the so I clicked on dashboard. Here I get different options, different things that Microsoft provides. So we'll use containers. We'll click on container. After clicking, we will get to see that what exactly is a Kubernetes cluster. So as our Kubernetes services manages your hosted Kubernetes environment, making it quick, easy to deploy uh, without container orchestration expertise. It eliminates burden of ongoing operation and maintenance by provisioning, upgrading, and scaling resources on demand. So it happens on demand, and we do not to worry about those things. So let's create a resource group. So for people who do not know what resource group are, resource group is nothing but you can think of it as small container or a folder where you can put everything that is important for your resources to work. So in this case, our resource is Kubernetes, but there are quite other few which is here, but we'll be using Azure Kubernetes. So at first we'll click on create new. At Let's say we give some name demo RG for demo. We'll have some simple name so that we can remember further. Okay, let's move to cluster name. Let's call it some name. Let's give it cube cluster. I think it's enough. It follows all the restrictions. Region, let it be US, Central US. Uh, but you can use whatever region is there. For let's use some random. Doesn't matter which you use. Let's say I'll select. Let's keep US, South Central US. So it'll ask how many nodes you want to create. So we'll use only one node. We'll keep it a simple demo. We discussed what node is in our previous video, and I'll click on review plus create. Or maybe before that, we can see some node pools or settings what Kubernetes clusters provide. In authentication, we'll see whether we want to run on server or cloud platform that to be managed. Uh, So here for us, the authentication method will be system assigned managed identity. We can also use service principal, which is an older way where we use Azure Activity Directory to do that. But no need to do this. I'll use service principal. Mm, It doesn't have a lot of impact on a demo. We'll do a review and create. So for creating this thing, it will review all the requirements. The requirements are reviewed. So what it do, it will go just ahead and create our cluster and put everything in place. We can see that validation passed. We'll create refresh. Let's do refresh. So Still deploying, we can see. Let's wait for deployment to get in place. Uh, After once deployment isn't done, we'll just put in certain set of commands and our job will be done. We don't have to wait for too long for that process. Let's refresh again and see if it's the outlet. Generally, it takes a couple of minutes. Um, uh, Let us see that what actually happens. So Kubernetes will go and launch some Linux launch in Linux instance, and whenever Linux instance is launched, we'll put forth our resources in that Linux instance, which will set up our cluster and all the integration that we'll need. And on top of that, our application will start to work. So here we'll place a cache. We'll refresh it and see what happens. Deployment is still in progress. Uh, so our deployment is completed. It's a fairly simple process. You can see how easily we deployed. Now uh, we'll go to resources. This is our status succeeded. We have one node pool. All the information is mentioned here. All the first information like where it is hosted and all stuff. Now let's open the shell. We are connected to a terminal. So moving forward, we'll use some command uh, AGAKS, and in this case, what we're going to do is we are gonna say get credentials. Now the next thing is what do we need? Resource group details. So we'll type dash dash resource dash group, and we'll give some resource group name. Uh, and we'll see here. Let's scroll up and see the resource name is RG for demo. As I mentioned that we should keep that in mind, RG for demo. And what we also need is we need the name of the cluster. And in that case, let's type cube clusters. We can start by giving details for our cluster and then detail for our resource groups. It can be done vice versa, but we use resource group. Uh, it's merged as current context in this path. Now, let's go ahead and get the details. In this case, we know that we need one node, but there may be multiple nodes. Let's type kubectl. It is basically a client-side interaction tool for interacting our Kubernetes. The kubectl get nodes. Press enter. If there are multiple nodes, we'll be getting multiple nodes. If there's only one node, it will give only one node. We can see here we got only one node. So we have all the details for that node. So we'll use this command further. Nano space Azure hyphen name of the application vote, and I'm gonna say .yaml. So I already have pasted a piece of code which I got the from Microsoft because I got the demo. I tried running the Azure before. So I'll remove this code first. I'll post the code again. So this is all the detail. What is the API being used? What is the container pulled? What is the memory that we are using? What call are you making? Or all it is are here. for getting the piece of code, you can just see Azure demo and we'll get this piece of code there itself. We'll get this code on GitHub as well. This is a Microsoft open code, so this hasn't been written by me. I just took from GitHub and it is somebody else's work. Let's remove. Yeah, everything is removed now. We'll go ahead and paste the piece of code here. Now I pasted it. All the same code is used again here with us. Now, how do I go ahead with this? In this case, I'll say I'll use exit for now. Control X. Yes. It will save my code now because I discard the changes, copied and pasted again. So it took back to my cluster. Next step is to will go ahead and call out this CML this file. So we'll say kubectl and we'll apply ff azure slash vote dot yaml. So this is the code. So we have a vote back application. Its front and backend is created as the command here describes. Azure vote back created, Azure vote front created. Using this command kubectl apply -f azure -vote dot ym. Let's type get service. So get service in place and let's type a azure minus dash vote. This is my app name and I want this time the front. So dash front and I'll say watch. Oh, okay. So I should have called this command kubectl. I should have used this. So kubectl get service azure vote front watch. And here we get an external IP. We have name, type, cluster IP, external IP, port, and age. So the age is 85 seconds. Normally it takes time, but here it's 85 seconds. We got luckily fast. Now I'll copy it. So here we can see the application. So here we can wait cats on dogs. As we click, the count increases. Reset to make it all 0. So this is how we actually go and create a cluster using Kubernetes. Let's delete the resources. Even there's are active directories. So as well, let's say track all the working that we have done. So in Insights, we can see all the details that we have done so far. So there we go. So here is all the details. How long did we use the cluster and all? So here we can see in this graph. So that's it. Thank you so much.